language, we're not doing a significance test. We're looking at the whole populations, and we're deciding whether the knowledge that one event happens affects the probability of the other. So the knowledge that event A happens doesn't change the probability of B. It's always the same. Okay? And the easiest way to think about that is with replacement. So if I'm thinking of a deck of cards, if I pull a card out of the deck, my probability of getting a certain other card is going to be out of 51 instead of 52. If I have replaced a card in the deck, then my probability of getting some card is out of 52 each and every time, because I keep replacing the card in the deck. So that's independence. If I take a card out, remove a card each time, then those are not independent events. Those are dependent events. So I kind of ran out of room here. If the events are dependent, so I'll write that over here in red, probability of A and B is the probability of A times the probability of B given A. That conditional probability, you know, there's one less card in the deck, so that, you know, I need that new probability that has one less card in the deck. Okay. Tree diagrams. So sometimes it's easy. It's fairly easy when somebody's giving you some information to set things up in a tree diagram, such as HIV ones are like. So either you got HIV. What? Oh, didn't like my example. It's because I'm giving an HIV example problem a little later. Either you have HIV or you don't. Either you test positive or negative. And then generally, the AND is traveling down the branch, and the ORs are adding things together at the ends of the branch. So let me see if I can. So the AND is down the branch, and the ORs are at the end of the branches. HIV test positive, or HIV test negative, or no HIV test positive, or no HIV test negative. That would be at the end of the branches. Probability of HIV and testing positive would be a multiplication down the branch. Okay. Two-way tables, we did a bit of those. You're either a sophomore, a junior, or a senior. You're either a male or a female. And then you either have some proportions in here, or sometimes you have actual numbers. So this space right here would be a male sophomore, and maybe there are 20% of those. And out of my population, 10% and 10% for 40, 30, 20 and 10 for 60%, 50, 30, and 20% for those totals. And then this space right here is an AND. If I want conditionals, if I want the probability that you're a male given that you're a senior, that is I only talk about the seniors in my, because my given says seniors, and a male that's a senior is 10% out of the total seniors, 2%. Okay. Yes, ma'am. Oh, stretching. Okay. Independent events. Two events are independent if the probability of A and B is equal to the probability of A times the probability of B. If you're given a two-way table, easy to check. Probability of male and senior is 0.10. Is that the probability of being a male? 0.4 times the probability of being a senior, 0.2. So male and senior is 10%. Is that equal to probability of a male, 0.4 times the probability of a senior? Are those equal? Not equal, then not independent. Okay? Conditional probabilities. Probability of A given B is the probability of A and B divided by the probability of B. So here's A and B, male and senior, out of probability of being a senior, 0.1 out of 0.2. Okay. Probability of at least one. Nice to remember that that is the same thing as 1 minus the probability of none. That'll buy you a lot. It's often asked on the AP exam. Random variables. Many of the questions on the AP exam involve random variables and finding expected values and standard deviations and such with random variables. So a discrete random variable, you can have for your probability experiments outcomes of 3, 6, and 10. And the probability of getting a 3 is 1/10. The probability of getting a 6 is 5/10, and then 4/10 for the rest. So often they'll have the table set up for you, or you have to kind of like put things into a random variable table like this, distribution. Continuous random variables, oh, that's like our normal distribution. AP exam generally has questions on probabilities from a normal distribution. Okay? The expected value, you'll be in the middle of a probability problem and they'll ask you for some kind of expectation. That's the mean of the random variable. And that is each value the x can take on times its probability